Welcome to video 10 in a series of introductory videos for the InventorCAM CNC programming software. This video's topic is 3D milling. So the 3D milling toolpath is essentially a three-dimensional version of the pocketing toolpath. You'll program it the same way. Just as a 3D toolpath, there will be additional functions to account for the fact that you're doing things in the third dimension. So let's begin by opening up a milling operation. We'll select 3D milling. As with other 3D toolpaths, the geometry is pre-selected as the target. So that is the solid that we defined when we first created this InventorCAM file. The only other geometry you'll select for the 3D milling toolpath is the working area. And I actually provided a brief description on what working area is, how it works, in video 9 of this series. We'll go to working area, engage the working area, define. And the working area is just going to be a contour selected from this geometry. So like we saw in the previous videos, I'm just going to choose right from the edge there. I'll do a constant Z propagation, and we've got the outer edge of the stock. I'll define that as external. I might even actually just expand it a little bit. So I'm going to expand it by 1 inch on all sides. We'll go to Tool. So I will select the tool. In this case, I'll go with my 1/2 inch end mill. Now, unlike what you saw in video 9 of this series, 3D milling actually needs you to provide the feeds and speeds. So I'll just plug them in the Data tab. Under Levels, much as you saw with the other 3D toolpath videos, the levels are essentially just an envelope that we'd like to machine within. So how much of the target falls in between these two levels is what we want to machine. Under Technology, you'll see that the interface is slightly different than what you would have seen for the pocketing toolpath in video 5 of this series, but essentially you're still choosing the same things. So in this case, I've decided to do a roughing toolpath. So I'll change this from none to one of the 3 types of pocketing toolpaths: hatch, contour, or plunging pattern. And we saw those options displayed in video 5 of the series. I'm just going to go with hatch. I'll define my overlap and my step down. In this case, I'll just change the step down to 250. 3D milling is very good for prismatic parts. So as we're going along and machining the scallops on curvatures, taper faces, or anything like that, we will probably encounter flats. So when do we do the flats? Either during the roughing or after the roughing. Wall offset, floor offset. Much as what we would have seen in the other series, whenever you're setting something up as roughing, you'll have the option of wall offset and floor offset. Under Z entry, we have control over the ramp, so how we'd like to enter into the part. I'll just leave that as none. Mode, as I said, this is somewhat of a pocketing toolpath, so we have the option here of either doing it as a pocket or a profile style toolpath for any open pockets. And under Data, you'll see the parameters specific to this type of roughing toolpath. In this case, because I chose hatch, I have hatch data. I can define the angle that the hatch will be at, cutting direction, zigzag, or one way, and what to do at the sharp corner. So either just a straight direct movement or a fillet. I'll just leave those as the base settings. Likewise, if I were to do this as a finishing toolpath, I have the finishing options in the lower right corner, and some of these are similar to the other strategies you'll see with some other finishing toolpaths later in the series of introductory videos. So let's just do a save and calculate on this, and we'll see how the 3D milling applies a 1/2 inch end mill toolpath to this part. So essentially what you see is my 1 inch working area on all sides. If I just kind of move this a little bit, you'll see that it's essentially just a zigzag pattern back and forth. If I open this back up, let's just switch that to contour. Now the parameters here are common to both hatch and contour. You'll see that under Data, though, we have a different set of parameters, again, specific to the fact that this will be a contour toolpath. Do a save and calculate on that. And now we have a contour style toolpath. So again, hatch versus contour is up to the programmer to see which one would be best fit for the type of geometry that he's working with. Now, much as other toolpaths inside InventorCAM, we have the ability to do a rest operation. So if I just open this back up, do a save and copy, I will change the size of the tool. So let's go with the 1/4 inch end mill. Levels will be the same. Technology, I'm just going to change my step down and my overlap. Actually, overlap I'll leave because that is 0.5 of the tool. I believe, let's just make that 0.26. Wall offset, floor offset is all the same. Now, to make this a rest operation, I'll just go to rest material, change it from none to rest. That opens up the data tab, and that allows me to tell it the previous tool diameter and the previous wall offset. Click OK, save and calculate. And we'll see that it will do the remaining material. In this case, all the corners and any tight areas that the previous tool could not get into. So any questions on this type of toolpath or anything else you see in the series, you can always call us at 1-866-975-1115 extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com, or stay tuned for the rest of the videos in this series. Thanks for watching.